Hey, also, been talking for some time about inferences like confidence intervals or hypothesis testing for proportions. And so now we're going to do something similar, but change gears a bit and talk about means. So today we're going to talk about confidence intervals for means. And it's been a little while, but remember that uh, the symbol for a sample mean is x bar. So that represents the mean of a sample. We have T star, which is like a Z star. It's a critical value, but it's associated with a T curve instead of a completely normal curve. And we're going to need to know a degree of freedom. The degrees of freedom is n minus 1. So your sample size minus 1. And then we have a standard error, which is very similar to the standard error for a distribution of sample means. We take the sample standard deviation divided by the square root of the number of people or things we sampled. And then we can build a confidence interval. We interpret it the same way. We have the same types of confidence levels like 95%, 90%, 99%. But this time we're talking about population means instead of population proportions. Of course, we have assumptions and conditions. Pretty close to the same. That last one you're going to notice is different. We need our sample to be random. We always have to sample randomly. We want to sample less than 10% of the population still. And then we need to check that our data is nearly normal. And one of the easiest ways to do that, especially if you've given data, is to just create a histogram, or we can create what's called a normal probability plot, which we can talk about more in class. So we're looking for a distribution that's unimodal and approximately symmetric, and then we can proceed as if our data is normal, approximately normal. So let's do an example. If you don't have a calculator at home, I've made some calculations for you. If you do have a calculator, that's great. Play along. So take a second, read this, and then we'll talk about it. So we have a professor that has randomly sampled 24 of her 250 students, and she wants to find, or he wants to find, he or she wants to find a confidence interval for the number of credit hours that her entire student population takes. So she samples 24 of them instead of asking all 250, and she wants to build a confidence interval to try and capture the true average number of credit hours her students take in a term. And so these are the credit hours for 24 students that she sampled. And what I did was I put them into my calculator. I did stat edit, and I put them into a list. And we're going to use that information as we make some calculations. We want a 95% confidence interval. Of course, the first thing we need to do is check assumptions and conditions. The professor took a random sample of 24 students, and the 24 students is just less than 10% of her 250 total students. So those two are good. I'm going to use that data that I input into my list and create a histogram and check that that histogram is nearly normal, unimodal, symmetric. It's not perfect, but it looks pretty symmetric. So I can move on and I can create a confidence interval. And so there's my interval. I need to find these values. I need to find the sample mean. I need to find the critical value associated with 24 students. And I need to find the standard error, which means I need the standard deviation of my sample. So in my calculator, I can calculate one variable statistics. I just hit stat calc, one variable stats. It's been a while since we've done this. Make sure you use the correct list, and this is what I got. I found a mean of 16.625 and a standard deviation of 2.222, so on and so forth. We use S instead of sigma because this came from a sample. So my x bar, my sample mean, is that 16.625. I'm going to find the standard error for my sample mean. I'm going to take that standard deviation from my one variable statistics and divide it by the square root of 24, the square root of the number of students, and get a standard error of close to 0.4532. And so now lastly, I need this t-star. I'm going to show you how to calculate t-star. I'm going to hit second vars, and we've calculated z-star by doing inverse normal. You can see hopefully right underneath it's inverse t. I'm going to put my area in there since it's a 95% confidence interval. There's 97.5% of the area underneath that curve, so 0.975. df is degrees of freedom. I take the number of people in my sample and subtract 1. So 24 minus 1 gives me 23 degrees of freedom. And my calculator would tell me that my t-star value is close to 2.068, and I round it up to 2.069. So now I can just plug all these in to my interval. And I end up with an interval here between 15.6873 and 17.5627. Just like with the other intervals and the hypothesis test, we have a function on our calculator that allows us to do this. And so I'm going to recommend that you do it by hand and using the calculator as a double check. When I do it in the calculator, I do stat tests, I choose a t interval, and you can see that I get close to what I got here. Of course, I did a little rounding when I did my hand calculations, so I'm off by a little bit from what the calculator got. But looks like we did a good job. And so now it's up to us to interpret this interval. So we were talking about a mean or average number of credit hours that this professor's students were taking. And we could be 95% confident that the true mean. Okay, so we are trying to make an inference about the actual mean number of credit hours her students take. Not just the 24 we sampled, but all of them. We're 95% confident the true mean number of credit hours the students in the professor's class take is between 15.69 and 17.56 hours. And as a reminder, that means that if we were to sample 24 students, every possible combination of 24 students out of the 250, 95% of the confidence intervals produced from those samples would contain the true mean credit hours. And so rather than doing all of that, we do it once and we can be 95% confident that our true mean credit hour is between those two values. So very similar, calculations are made a little bit differently. We'll talk about it a bit more together in class. Make sure you come prepared with questions, and we'll do some practice together as well.